All right, I'm going to use a lot of colors, so if you need colors, there's markers up here. I'll be using like about 7 different colors, and there's also markers on my desk right there if you want that kind. Well, that's fine. As I say, you may not want the fatter Sharpies. You may want the smaller ones, but I don't personally care what you use.
No. You can just take all of them.
There's other ones over in my thingy too.
I feel cheated.
Those are better. All right, so I'm gonna start out with degrees. So I start out, work my way around 0 degrees, then 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and all the way back around to 360 degrees. All y'all get those, and then we'll do radians next. Yeah, I'm gonna switch colors. I'm using green, but it's totally up to you.
When is this quiz gonna be?
A week away,
A week from today?
pretty much, yeah. We might do a practice quiz on Thursday and then the real one on Friday. But if you do well enough on the first one, you don't have to take the second one.
Oh, yay.
So
Okay.
the first day is kind of just like, what do you know? And if you happen to know it all, that's great. And I will take the higher of the two. So let's say you take it and you get like a 90 on Thursday, but then on Friday you get an 85. Like, I'm going to take the 90.
Okay.
So, and if you get over 100 or over, because I build in 2 extra like points of extra credit, if you get over 100 or 100, you don't have to retake it. But anything under 100, you have to retake it. All right, so radians. I'm going to do the axis points first, and so I'm going to show you how I count it, and then I'll go through and I'll count in pi over 4s and so on and so forth. So start out at 0. That's really hard to see. We're going to change the shade of green. Dark green. So 0. So then we're in increments of pi over 2. So 0. It says 1 pi over 2. So pi over 2. Coming around is 2 pi over 2, which is just pi. Then coming down is 3 pi over 2. And then all the way around is 4 pi over 2, which is 2 pi. So then I'm going to do the increments of 45 degrees counting because that's the next like easiest one to do. So those are increments of pi over 4. So we start at pi over 4. So that's 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, then 4 pi over 4, which is pi, then 5 pi over 4, 6 pi over 4, which is 3 pi over 2, it's already there, then 7 pi over 4, then all the way around is 8 pi over 4, which is 2 pi. So the denominator is how many sections it's broken up into in the top, but it's always reduced down. So that's why, like, you're going to notice I've counted the pi over 2's with this one. But that's because it's just reduced. So I'm going to do the pi over 3's next, and I'll do pi over 6's last. So pi over 3 is broken up into 3 sections. So 0, then we have pi over 3, which is occurring at 60 degrees. So pi over 3. No, I'm using the same color for all the radians. So pi over 3, then 2 pi over 3, then 3 pi over 3, which is pi. Then on around is 4 pi over 3. Then 5 pi over 3. And then 6 pi over 3, which is 2 pi. So now when I do the pi over 6's, it's going to include also just reduce down the pi over 3's and the pi over 2's. Okay, so that's why I saved those for last, because they will be reduced for there will be reduced versions of them for other stuff on here. So they are occurring every 30 degrees, so it's in increments of 6 at the top. So start out at pi over 6 at 30 degrees. So that's 1 pi over 6. Then 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. 5 pi over 6, which we have to write in. Then 6 pi over 6 reduces to pi. Then I keep going. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. Then 11 pi over 6. This is the last one that I have to write in. And then 12 pi over 6 is 2 pi. So that's all your radians. Now I'm going to actually draw on my axis now. I'm going to be filling in x and y values now. So obviously x-axis, y-axis. So I'm going to do, in a different color, I'm going to do my, oh, not that. Axis points. So this point out here is 1, 0. Up here is 0, 1. Over here, -1, 0. Then down here, 0, -1. Well, it's a different color than what I've been using. It kind of looks the same, but it's green and black. All right, I'm switching colors again. All right, now visually, I'm going to draw something on here, but I'm going to erase it, so this is more just for you to see it. If you want to write it, draw it, you can, but I'm looking at this point, and I want to know what the x and y value is. So in terms of intersecting, okay, this point here is beyond half. It's almost all the way out to 1, okay? So this is the x value is square root of 3 over 2. Okay, which comes out to be about 0.866. Okay, so that's how you can remember that one's almost all the way out to 1. So that's a square root of 3 over 2. Then this point is about halfway between, so that's 1/2. And I say about because my drawing's not perfect, obviously. So that point is the square root of 3 over 2 and 1/2. Now, all of the points that actually have a pi over 6 on them are the same values for x and y. The signs just change. So in this quadrant, both things are positive. I come over here to 5 pi over 6, okay? Same points, but over here my x values are negative, y values are positive. So it's going to be negative square root of 3 over 2, positive 1/2. Then down at 7 pi over 6, x is negative and y is negative. So this is going to be negative square root of 3 over 2 and negative 1/2. And then all the way over at 11 pi over 6, x is positive, y is negative. So it's going to be the square root of 3 over 2, negative 1/2. Switching colors again. So now I'm going to do the pi over 4s. So, again, trying to get it as close as possible. I'm just, again, drawing visually. I'm going to erase that stuff. So, this point is obviously less than the square root of 3 over 2, but it's more than 1/2. So it's going to be the square root of 2 over 2. And that's actually going to be both points. So I think the pi over 4s are the easiest because it's square root of 2 over 2 for both. And that value is like 0.707 or around there. So it's a little less than that, if that helps you remember. So this point goes on all the pi over 4s, and again, the signs are the only difference in them. So at 3 pi over 4, we have negative square root of 2 over 2 and the square root of 2 over 2. At 5 pi over 4, both are negative. So it is negative square root of 2 over 2 and negative square root of 2 over 2. 7 pi over 4, x is positive, y is negative, so square root of 2 over 2, negative square root of 2 over 2. And then lastly, I have the pi over 3s for in terms of the x, y points. So I've got I have whiteout. I might have the tape stuff. Almost. All right, so pi over 3. I've got it here coming down. So notice that my y value is about halfway between, my x value is about halfway between, my y value is up here almost all the way to 1. So this is going to be 1/2 and then square root of 3 over 2. And just like the others, that occurs all the way around. The signs just change. So at 2 pi over 3, it is negative 1/2 square root of 3 over 2. 4 pi over 3, they're both negative, so negative 1/2, negative square root of 3 over 2. And 5 pi over 3, positive 1/2, negative square root of 3 over 2. So notice the pi over 3s and the pi over 6s are opposite in terms of x and y. Okay. But all of the ones that have the same denominator on them go together.
Is that it?
We haven't put tangents on there yet.
Right.
So, no, not yet.
I knew that we were missing something, and I was trying to figure out what it was.
All right, I'm getting rid of these lines because they irritate me being on there. All right, so tangents are the last thing.
Gross.
Oh, man. All right, so tangent values, I'm going to do the axis points first. Okay, tangent is y divided by x. So 0 divided by 1 is what? 0. 1 divided by 0 is, nope, undefined. 0 divided by negative 1 is 0. And negative 1 divided by 0 is undefined. Alright, then over here, 1/2 divided by the square root of 3 over 2. When you multiply, the 2's cancel, so you have 1 over the square root of 3. We rationalize it. It gives you the square root of 3 over 3. And so, all the way around, wherever I have the pi over 6's, the tangent value is the square root of 3 over 3. The difference is the sign, again. Over here, we have a positive divided by a negative, so it's going to be negative. So, negative square root of 3 over 3. Down here, I have a negative divided by a negative, so it's going to be positive. So, square root of 3 over 3. And then over here, I have a negative divided by a positive, so that's going to be negative square root of 3 over 3. So, quadrants 2 and 4 are negative, 1 and 3 are positive for the tangents all the way around. So pi over 4's square root of 2 over 2 divided by a square root of 2 over 2. When you multiply, everything's going to cancel. So those are all 1. And again, the sign just changes. So over here, negative 1. Down here, positive 1. And back over here is negative 1. And then lastly, my pi over 3 is square root of 3 over 2 divided by 1/2. When you multiply by 2, you just are left with the square root of 3. So then you have square root of 3 all the way around. Again, the signs are just the difference. So negative square root of 3, positive square root of 3, and negative square root of 3. Any questions about that? I'm going to show you my hand method for memorizing, just in case it helps you. But there's also a song that, it was funny. Garrett was in the office the other day, and I said something about the unit circle, and he's like, "Oh, I memorized a song for that." I was like, "Yeah, I know. I use that as an example all the time." But there's some song to memorize the unit circle. Some people are better off just memorizing it. Some people are better off just knowing how to find it mathematically, which I think is harder, but if you're not great at memorizing, it's kind of a good option. So I'll show you that in a second, but I'm gonna turn this off first.